Today we are trying May June 2017 paper 12. Find the coefficient of x in the expansion of 2x minus 1 over x to the power 5. Let's try this. So I'm writing 2x minus 1 over x to the power 5. I know tr plus 1 is ncr p to the power n minus r q to the power r, where n is 5, p is 2x, and q is negative 1 over x. Substitute the values. So tr plus 1 becomes 5cr 2x to the power 5 minus r negative 1 over x to the power r. We need coefficient of x. So collecting powers of x only, we have so we can write x to the power 5 minus r. That's what the term I need, x and x. I don't need the 5cr, I don't need the negative term, I don't need the 2. So I'm writing x to the power 5 minus r over x to the power r is x to the power 1. So x to the power 5 minus r, x to the power 1. I know a to the power m over a to the power n is a to the power m minus n. So x to the power 5 minus 2r is x to the power 1. 5 minus 2r is 1. So 5 minus 1 is 2r. 2r is 4, which means r is 2. Substitute the r equals 2. So I'm writing it's 5cr times 2x. I'm substituting the 2x to the power 5 minus 2 negative 1 over x to the power 2, which is 10. 5cr is 10. 2x to the power 3, 8x cubed times negative 1 over x to the power 2, 1x squared, which is same as 80x. Therefore, coefficient of x is now, hence find the coefficient of x in the expansion of 1 plus 3x squared, 2x minus 1 over x to the power 5. Now, from the previous part, we have the coefficient of x is 80. What is remaining now? To multiply with x squared, if I have x to the power negative 1, which is 1 over x, that term, then that also gives me x. So I'm trying x to the power 5. Okay, let me write like this. Using part 1 for term containing 1 over x, we have x to the power 5 minus 2r equals x to the power negative 1. So 5 minus 2r, I already had it. So here I had compared it with x to the power 1. So now I will compare it with x to the power negative 1. Negative 1. Therefore, r is 3. So term containing 1 over x is 5c3. Then 2x to the power 5 minus 3. Negative 1 over x to the power 3. 10 times 4x squared times negative 1 over x cubed, negative 40 over x. Now 1 plus 3x squared times 2x 1 over x to the power x 5 is, now I'm just writing terms with x and x 1 over x, so that it will just multiply with the previous terms, and then which is 1 plus 3x squared, and give me the required answer. So I'm writing 1 plus 3x squared 80x minus 40 over x. So collecting terms with x only, 80x minus, so I'm writing like that, I can write like that, 1 times 80x plus 3x squared times that negative 40 over x, 80x minus 120x negative 40x. Therefore, coefficient of x negative 40. Let's try the next one. Number 2 now. The point a point A has coordinates negative 2, 6. The equation of the perpendicular bisector of the line AB is 2y equals 3x plus 5. Find the equation of AB. So I have equation of perpendicular of AB, which is 2y equals 3x plus 5. I need to change it into the form y equals mx plus c. The reason behind doing that is I need the gradient. So I'm trying that. I'm dividing throughout by 2. So y equals 3 over 2x plus 5 over 2. Therefore, gradient of the line, given line, which is perpendicular to AB, is 3 over 2. Therefore, gradient of AB line, which is negative 1 over 3 over 2. What we know about perpendicular lines, the perpendicular line to anything will have gradient negative 1 over m. So that's, I can write m2 is 1 over m1, negative 1 over m1. So I get perpendicular line to A, the line AB will have gradient negative 2 over 3. All right, equation of AB, y minus y1 equals mx minus x1. You can try y equals mx plus c also, whichever form you are comfortable with. I am writing here y. Now I need the point and gradient. The point x1, y1 I have is negative 2, 6, and the gradient I have is negative 2 over 3. I'm using that. Y minus 6 is negative 2 over 3, x minus negative 2. Multiply throughout by 3. Why am I multiplying throughout by 3? I want to get rid of that 3. So 3y minus 18 is negative 2 times x plus 2. 3y minus 18 is negative 2x minus 4. I'm sending 18 to the other side and 2x to the other side. So I can say 2x plus 3y is negative 4 plus 18. So 2x plus 3y is 14. Find the coordinates of B. Now we need coordinates of B. Let's try this. Equation of AB. We have 2y equals 3x plus 5. That was equation of perpendicular line to AB. Now equation of AB. We got it. That was that. Perpendicular line had equation that. All right, so I'm writing it is 2x plus 3y is 14. So I can write 3y is negative 2x plus 14, divide throughout by 3. Y is negative 2 over 3x plus 14 over 3. Now I have these two equations. One is that, and I can use this to change it, divide by 2 throughout, 3 over 2x plus 5 over 2. This is equation 1 and that's equation 2. Compare them to get the values of x. So I'm writing 3 over 2x plus 5 over 2 equals negative 2 over 3x plus 14 over 3. Bringing like terms, x's together, constants together, 3 over 2x plus 2 over 3x is 14 over 3 minus 5 over 2, which becomes, I can use calculator, 3 over 2 plus 2 over 3. That makes it 13 over 6x equals 28 minus 15. That is 13 over 6. So that's x is 13 over 6 times 6 over 13. Gives me x equals 1. Now substitute x equals 1 in equation 1. I get y equals 3 over 2, 1 plus 5 over 2. 3 over 2 plus 5 over 2, which is 8 over 2. So y is 4. Therefore, coordinates of midpoint AB are 1, 4. Why is it midpoint? That was A and B. If I take perpendicular bisector, bisector means it bisects the line segment into two parts. So these two and these two are equal, which means the M is the midpoint of both. So M, I got the coordinates of M are 1 and 4, out of which I know A is, so let's try, A is negative 2, 6. M is 1, 4. Let's say B is xy. So I can say it is equation of midpoint. Midpoint is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So I'm trying negative 2 plus x divided by 2 is 1, which means negative 2 plus x is 2, x is 4. Then I'm trying for y now. 6 plus y divided by 2 is 4. So 6 plus y is 8, y is 2. Therefore, point B has coordinates 4, 2. Let's try the next one. Prove the identity. 1 over cos theta minus tan theta squared is 1 minus sin theta over 1 plus sin theta. Now left hand side, I'm writing 1 over cos theta minus tan theta is sin theta over cos theta. So I'm cross multiplying. So that's 1 minus sin theta. I don't need to cross multiply, in fact. I can just take common denominator. It's the cos theta. So I can try this instead of cross multiplying. When I cross multiply, I'm getting extra terms. So let's try this. 1 minus sin theta over cos theta squared. In trigonometry, whatever comes to your mind first, you should try that first. Whatever you do, you will get the answer, no matter whatever you do. So you try this. So I'm writing, giving each term its own power. So it's 1 minus sin theta squared over cos theta squared, which is cos squared theta. 1 minus sin theta squared. Now what I need in the numerator is 1 minus sin theta. I got, but it is 1 extra. So I have to get rid of that. But I don't want anything with cos theta in the denominator. What I need is 1 plus sin theta. So I'm changing cos squared into sin squared, which is 1 minus sin squared theta. So 1 minus sin theta squared over 1 squared minus sin theta squared. 1 minus sin theta squared over 1 plus sin theta and 1 minus sin theta. Got rid of that. So I got 1 minus sin theta over 1 plus sin theta. Right hand side. Let's try the next part. Now, number 2. Hence, solve the equation. 1 over cos theta minus tan theta squared is half for 0 degrees less than equals theta less than equals 360 degrees. Using the results from part 1, I can write in place of that, which is 1 over cos theta minus tan theta squared. I can write 1 minus sin theta over 1 plus sin theta. 1 minus sin theta over 1 plus sin theta. Remember, whenever they say hence, that means you have to use the previous result. So which is half. I'm cross multiplying. This case I'm cross multiplying now. 2 1 minus sin theta equals 1 times 1 plus sin theta. 2 minus 2 sin theta equals 1 plus sin theta. Sending 1 there, 2 sin theta there. So that becomes 2 minus 1 is sin theta plus 2 sin theta. So 1 equals 3 sin theta. So sin theta is 1 over 3. Now basic angle alpha is sine inverse 1 over 3. So I'm using calculator. So when I'm using calculator, I get sine inverse 1 over 3. Alpha is 19.5 degrees. Now my sine is positive here. Sine theta is positive. Now I have to figure out where is sine theta positive. So I'm writing all S, T, C. So sine is positive in the first quadrant and second quadrant. First quadrant theta is theta. Second quadrant theta is 180 minus theta. So I'm writing theta is 19.5 and 180 minus 19.5. So theta is 19.5 degrees, and use calculator again to give you 160.5 degrees. Let's try question number 4 now. Question number 4. The diagram shows a circle with radius r centimeters and center O. Points A and B lie on the circle, and ABCD is a rectangle. Alright, so I'm trying this. I'll use different color so that we understand. Alright, ABCD is a rectangle. That's what they've said. Angle AOB is 2 theta radians and AD is r centimeters. Express the perimeter of the shaded region in terms of r and theta. Now, perimeter of the shaded region, let me try this. What they want is, it's that part, that, then that, and that, right? That's what we need. All right. So let's try this. In triangle, in triangle OAP, right? That's, I'm saying that, let me divide that into that's P. Triangle AOP. So I can draw that here. That's A, that's O, that's P. The full, that full angle was 2 theta radian. So half the angle will be theta radian. Why half? Because whenever you draw a perpendicular bisector, it divides the angle into half. So 2 theta becomes theta. So I'm writing now. In triangle AOP, theta is opposite over hypotenuse. Hypotenuse was r, right? So I'm writing sine theta is opposite over hypotenuse. So sine theta is opposite is AP or over r. Therefore, AP is r sine theta. Now, let's try this. What AB equals DC, which is AD equals DC. So r sine theta. That was half part was r sine theta. So the double of it, which is AB, will be 2r sine theta. That's so I got AB equals DC equals 2r sine theta. Next one, we need arc length AB. So arc length AB is, why did we calculate this part first of all? Because we needed that. Then we know this is r, and we need the arc length. So now we are calculating arc length. Now arc length AB is, it is r theta. Here r is r, but theta is 2 theta. So arc length AB is 2r theta. I got that. Next one, so perimeter of the shaded region equals AD plus DC plus BC plus arc length AB. AD is R, DC is 2r sine theta plus BC is R plus arc length AB is 2r theta. So I can write equals 2r plus 2r theta, 2r sine theta, which is same as 2r common in all, 1 plus theta plus sine theta. All right. Number 2, part 2 now. In the case where r is 5 and theta is 1 over 6 pi, find the area of the shaded region. Now area of the shaded region, let me draw the part again because it's difficult for us to see each time. Go up and check for the diagram. So let's draw that. All right, then I have this, I have that part, that's Q, let me say that's Q, that's A, that's B, that's O, that's D, that's C. All right, that angle is 2 theta, that's radius is r, that's also r centimeters. So, and that is also r. All right, let's try it now. Area of rectangle ABCD. Now it says find the area of the shaded region. So what we need is area of the rectangle minus area of that part which is that segment. So that's what we are trying. What is segment? Area of the sector minus area of the triangle. So we'll try that. Rectangle ABCD is R times, now from previous part DC was 2r sine theta. So that's 2r sine theta, which is 2r squared sine theta. Now given r is 5 and theta is 1 over 6 pi. So I'm substituting the values. So area is 2 times 5 squared times sine pi over 6. Use calculator. Make sure that your calculator is in radian mode before you start. So it's 50 times half, 25 square centimeters. Now area of segment, AQBA, the green part I'm talking about. It's half r squared theta, area of the sector, minus area of the triangle, which is half AB sine C. Half r is r squared theta is 2 theta, minus half A is r, B is also r, and sine theta is sine 2 theta. So that is, I can get rid of half and 2, so that's r squared theta minus half r squared sine 2 theta. I'm substituting now the values. R is 5, so 5 squared theta is pi over 6, minus half 5 squared sine 2 times pi over 6. So 25 times pi over 6 minus 25 over 2 sine pi over 3. So that's, I can write 25 pi over 6 minus 25 over 2. Sine pi over 3 is root 3 over 2. So 25 pi over 6 minus 25 root 3 over 4. All right. So that's same as, use calculator, 2.265 square centimeters. Now area of the shaded region is area of the rectangle minus area of the segment. Area of the rectangle was that, and area of the segment is that. So I'm subtracting that. Therefore shaded area of rectangle minus area of segment, which is 25 minus 2.265, 22.7 square centimeters. Let's try next one. Now next one is question number 5. A curve has equation y equals 3 plus 12 over 2 minus x. So I'm writing the equation 3 plus 12 over 2 minus x. Find the equation of the tangent to the curve at the point where the curve crosses x-axis. Number 2, a point moves, okay, let's try for one first. A point moves along the curve in, okay, let's try one first. Find the equation of the tangent to the curve at the point where the curve crosses x-axis. All right. So I'm writing y equals 3 plus 12 over 2 minus x. The curve crosses x-axis. When the curve crosses x-axis, substitute y equals 0. 0 is 3 plus 12 over 2 minus x. So I'm writing 3 equals negative 12 over 2 minus x, sending 12 over 2 minus x to the other side. I'm cross multiplying. 3 times 2 minus x is negative 12. 6 minus 3x is negative 12. Send 6 to the 3x there and 12 there. So it's 6 plus 12 is 3x. 3x is 18. X is 18 over 3. X is 6. The curve crosses x-axis. The curve crosses x-axis at the point 6, 0. Now, equation of curve. Y equals 3 plus 12 over 2 minus x, which is y equals 3 plus 12, 2 minus x to the power negative 1. We are trying to figure out what's the gradient. So dy over dx is 0, 12, -1, 2 minus x to the power -2, which is same as -12, negative and negative is 0, and times -1, because that's coefficient of x is also -1. So negative is positive. 2 minus x to the power -2. So dy over dx is 12 over 2 minus x to the power 2. All right. At x equals 6, gradient of the tangent is dy over dx at x is 6, 12 over 2 minus 6 squared, 3/4. Therefore, equation of tangent passing through 6, 0, I can write y minus y1 equals mx minus x1. You could use y equals mx plus c. So I'm writing the point is 6, 0. So that's x1, y1. And m is 3/4. That's m. So I'm using that and that. So I'm writing y minus 0 is m 3/4 x minus 6. So multiply throughout by 4. So 4y is 3 times x, 3x, minus 3 times 6, 18. All right. Equation of the tangent. So equation of the tangent is that. Let's try the next part. Next part says a point moves along the curve in such a way that the x coordinate is increasing at a constant rate of 0.04 units per second. Now remember, whenever they say rate is always per time. So it is, if it is x coordinate, so dx over dt. If it is y coordinate, dy over dt. Find the rate of change of y coordinate when x is 4. So I'm writing dx over dt is 0.04 units per second. From part 1, we know that dy over dx is that dy over dx is 12 over 2 minus x squared. Now it says when x is 4. So dy over dx when x is 4 is 12 over 2 minus 4 squared. 12 minus -2 squared, 12 over 4, which is 3. Using chain rule, dy over dt equals, okay, let me try like that. Dy over dx is dy over dt over dx over dt. That makes it a bit easier. Now dy over dx we have calculated, it is 3 equals, we have to calculate what's dy over dt, and we have dx over dt, which is 0.04. I'm sending to the other side. So 3 times 0.04 is dy over dt. So dy over dt is 0.12 units per second. Let's try question number 6 now. The diagram shows the straight line x plus y equals 5 intersecting the curve y equals 4 over x at the points 1 and 4, and b 4, 1. Find, showing all necessary working, the volume obtained when the shaded region is rotated through 360 degrees about x-axis. Now whenever questions like this, you should remember that what we are trying is the top curve minus the bottom curve. So which means what we are doing is area under the top curve minus area under the bottom curve will give us the area in between. So that's what I will do. Area of the line, area under the line, area of the region under the equation of the line minus area of the area under the curve. All right, let's try that. So required volume. First, let me write two equations. One equation is y1, which is, okay, x plus y is 5. So I'm writing y is 5 minus x. So y1 is 5 minus x. The other is y is 4 over x. So I'm writing y2 is 4x negative 1. When you write in this form, it becomes easier to integrate. Question 6. The diagram shows the straight line x plus y equals 5 intersecting the curve y equals 4 over x at the point A14 and B41. Find showing all necessary working the volume obtained when the shaded region is rotated through 360 degrees about x-axis. So whenever we have questions like that, even if it is area between them or the volume, so we have to try the top curve minus the bottom curve. So here we will try with the top curve minus bottom curve. So top curve is equation is y equals 5, x plus y is 5. So I'm setting y to the other, x to the other side. So y is 5 minus x. So I'm writing equation of the curve that which is line y1 is 5 minus x. Line is also a curve. It's just that it's a linear curve. So second part is y equals 4 over x. So I can write it as 4x to the power negative 1. When we write in this form, it becomes easier to integrate or differentiate. So y2 is 4x negative 1. Required volume. What's the formula of volume? Volume is pi integration of y squared dx. If it is through x-axis. If it is about y-axis, then v equals pi integration x squared dy. Here we have about x-axis. So we don't need this. We need that. So I'm using that. Required volume is pi integration. And now we have this. We start from there to there. Here the x coordinate is 1 and here x coordinate is 4. So we need the volume between 1 to 4. So that's 1 to 4. y1 squared dx minus pi integration 1 to 4 y2 squared dx. All right, so that's pi integration 1 to 4 5 minus x squared dx minus pi 1 to 4 4x negative 1 squared dx, which is pi. I can write 5 minus x cubed over 3 times negative 1. Coefficient of x is negative 1, so I'm multiplying by negative 1. 1 to 4 minus pi. So I'm writing here. That's, I can, let me simplify that. So I'm writing integration 1 to 4. 4 squared is 16 and x to the power negative 1 times 2 is x to the power negative 2 dx. So that's pi over negative 3. 5 minus x cubed 1 to 4 minus 16 pi. Then I'm writing integration 1 to 4 x to the power negative 2 dx. So that's, if you want to leave negative 3 inside, that doesn't matter. If you find it easier, let it be inside, doesn't matter. So I'm writing, I like it outside, so let me keep it outside. Negative pi over 3. Then I'm writing that's 5 minus x cubed 1 to 4. So I'm writing 5 minus 4 cubed minus 5 minus 1 cubed. And that becomes negative 16 pi x to the power 3, negative 3 over negative 3. Sorry, it becomes x to the power negative 1 over negative 1. That's the integration we are talking about. So it is integration of x to the power n dx will be x to the power n plus 1 over n plus 1. So you add negative 2 plus 1 is negative 1 over negative 1. So that becomes negative pi over 3. That becomes negative 63 plus 16 pi. That's negative, and negative becomes positive, and 1 over x, which is 1 to 4. So that's 63 divided by 3, and negative is positive, 21 pi plus 16 pi quarter minus 1 over 1. So that's 21 pi plus 16 pi times negative 3 quarters. So it's 21 pi minus 12 pi, 9 pi units cubed, or you can write it as approximately 28.3 units cubed to 3 significant figures. Let's try next question, number 7. The first two terms of an arithmetic progression are 16 and 24. Find the least number of terms of the progression which must be taken for their sum to exceed 20,000. All right. Now we know that A, first term, let me write like that. Arithmetic progression A plus D, A plus 2D, plus A plus n minus 1 times D. So arithmetic first two terms. First term is 16, so A is 16, and A plus D is 24. That's so A plus D minus A, which is second term minus first term, is 24 minus 16, which gives me D equals 8. So I have A is 16 and I have D is 8. Now it says the sum to exceed more than sum to exceed 20,000 means Sn is more than 20,000. Now what's the formula of Sn? Sn is n over 2, 2a plus n minus 1 times d. I'm using that. So n over 2, 2a. A is 16, n minus 1 times d. D is 8. Is more than 20,000. So that's, I'm multiplying throughout by 2. So that becomes n 32 plus 8n minus 8 is more than 40,000. So it's 8n squared. 32 minus 8 is 24. 24 n is more than 40,000. I'm sending 40,000 to the other side. So that becomes 8n squared plus 24n minus 40,000 more than 0. I'm dividing throughout by 8. So that becomes n squared plus 3n minus 5,000 is more than 0. Using quadratic formula, which we have to compare with ax squared plus bx plus c equals 0, gives me a is 1, b is 3, and c is negative 5,000. So the quadratic formula is x equals minus b plus or minus square root of b squared minus 4ac over 2a. Remember, everything over 2a, not only square root of that. So it's minus 3 plus or minus square root of negative, that's positive 3 squared minus 4 times 1 times negative 5,000. Everything over 2 times 1. So that's negative 3 plus or minus square root of 20,009 over 2. So I can write n is 69.2 or n is negative 72.2. We can use calculator for that. So the quadratic inequality becomes n minus 69.2 and n plus 72.2 is more than 0. So critical values, I can write n is 69.2, n is negative 72.2. So I'm using that, negative 72.2 and 69.2, right? But we cannot use that, right? We have to use only that positive value. No need of drawing that also. So I can write n is 69.2 because ignored. Why is it ignored? It's the negative value. So n is more than 69.2. I'm writing n is more than 69.2. Now, here if you don't understand what it is, that value is negative 72.2 and 69.2. What we need is more than 0. More than 0 are these values, right? So that is n is less than 72.2 or n is more than 69.2. That's what I was trying to say. So n is more than 69.2. Therefore, the least number of terms required more than 69.2 is integer number. Integer value is 70. So n is 70. Let's try number B now. A geometric progression has a first term of 6 and a sum to infinity 18. So I'm writing geometric progression first. A plus AR squared, AR n minus 1. A is 6 and S infinity is 18. Now S infinity is A over 1 minus R. Now S infinity is 18, so I'm writing 18 equals, what's A? A is 6 over 1 minus R. I'm multiplying that, so I'm sending they and 18 there. Therefore 1 minus R is 6 over 18. 1 minus R is 1 over 3. Sending R there, 1 over 3 there. 1 minus 1 over 3 is R. R is 2 over 3. I got R is 2 over 3. All right. Original geometric progression is A. So geometric progression is A. Original GP A, AR squared becomes, now A is 6 times 2 over 3, then 6 times 2 over 3 squared, and so on, right? Now new geometric progression, new GP, it is 36 times 2 over 3 squared, then 36 times 2 over 3 to the power 4, and so on, right? So for this progression, we have A is 36, then R is 2 over 3 squared, which is 4 over 9. S infinity is A over 1 minus R. So that is same as A is 36 over 1 minus 4 over 9. Using calculator will give me 324 over 5 or 64.8. Let me try the next one. Relative to origin. Okay, that's vectors. We don't have in our this syllabus for this year. So let's leave it. Question number 9. The equation of a curve is y equals 8 root x minus 2x. Find the coordinates of the stationary point of the curve. So I'm writing y is 8 root x minus 2x. So dy over dx is, I can rewrite it as y equals 8x half minus 2x. That makes it easier to try. Alright, so I'm trying equals 8 half x to the power half minus 1 minus 2. So that becomes 8 times, that's 4 x to the power negative half minus 2. So dy over dx is 4 over root x minus 2. Stationary point. At stationary point, dy over dx is 0. 4 root x minus 2 is 0. 4 root x equals 2. Setting this day. 4 over 2 is root x. So root x is 2. X is 2 squared, 4. Substitute x equals 4 into the equation of the curve. So y equals 8 root 4 minus 2 times 4 it gives me y equals 8. I can use calculator. Therefore, coordinates of the stationary points are 4, 8. Now it says find an expression of d squared y over dx squared and hence or otherwise determine the nature of the stationary point. So first we have dy over dx we have calculated, and dy over dx we got 4 over root x minus 2. I'm using that. So 4 over root x minus 2. What's d squared y over dx squared? Second derivative. So I'm trying that. D squared y. Alright, let me write it in the simpler form. 4 x to the power negative half minus 2. So d squared y over dx squared becomes 4 times negative half times x to the power negative half minus 1, and 2 becomes 0. So that is negative 2 x to the power negative 3 over 2. Now at determine the nature of the stationary point. We have x equals 4. I can use that value. D squared y over dx squared at x equals 4. So d squared y over dx squared at x is 4. Negative 2 times 4 to the power negative 3 over 2. Negative 2 times 1 over 8. Negative quarter less than 0. Therefore, the stationary point is a maximum point. Alright, number 3. Find the values of x at which the line y equals 6 meets the curve. Substitute y equals 6 into the equation of the curve. What's the equation of curve? Equation of the curve is that given to us 8 root x y equals 8 root x minus 2x. So I'm writing that y equals 8 root x minus 2x. X is 6, y is 6. 6 is 8 root x minus 2x. Let root x be t. So x will be t squared. What is the point of doing this? I want to change it into quadratic equation so that I can solve it. When it is in the form of square root, it's difficult for me to understand. So for you, but it makes it easier when it is quadratic. We know quadratic equation since form 4, so we can use that. So that is 6 equals 8t minus 2t squared. So I can change it into the form, sending all this to the other side. 2t squared minus 8t plus 6 equals 0. Divide by 2 throughout. T squared minus 4t plus 3 equals 0. So the factors of these equation are t minus 3 and t minus 1 equals 0. So t is 3 or t is 1. But t was square root of x. So square root of x is 3 or square root of x is 1. Which means x is 3 squared. Sending square root to the other side squares the other side. Or x is 1 squared. So x is 9 or x is 1. Both values of x satisfy the original equation. Therefore, x is 1 or x is 9. Let's try the next one. Number 4. State the set of values for k for which the line y equals k does not meet the curve. When the line does not meet the curve, we know it is b squared minus 4ac less than 0. So I'm saying substitute y equals k into the equation of the curve. That makes it 8 root x minus 2x is k. 2x minus 8 root x, plus k is 0. Since line does not meet the curve, b squared minus 4ac is less than 0. Now we have seen by substituting x, square root of x is t, so x becomes t squared. So we know that is, if we compare this with ax squared plus bx plus c, a is 2, b is negative 8, and c is k. So b squared negative 8 squared minus 4a 2, c is k is less than 0. 64 minus 8k is less than 0. So I'm sending 8k there. So that gives me 64 is less than 8k. That's easier when I write like this. 8k is more than 64. Divide both sides by 8. So k is more than 8. That's my final answer. Number 10. The function f is defined by fx is 3 tan half x minus 2 for negative half pi to positive half pi. Solve the equation fx plus 4 equals 0, giving your answer correct to 1 decimal place. Okay, fx plus 4 equals 0. Substitute into the place of fx the equation. So I'm writing that 3 tan half x minus 2 plus 4 equals 0. So 3 tan half x is negative 2. I'm sending that to the other side. Negative 2 plus 4 is positive 2. Goes to the other side, becomes negative 2. Therefore, tan half x is negative 2 over 3. Basic angle alpha is tan inverse 2 over 3. Remember, we do not need negative or positive sign in the equation when we are writing basic angle alpha, which means it has to be positive only. So tan inverse 2 over 3. I have to decide all STC. 10 is negative there, and second and fourth quadrant. Second quadrant, it is pi over 2 plus theta. Okay, now here, that's, okay, let's try that. Pi over 2 plus theta. So let me try, that's not pi over 2. I can try pi minus theta, and that fourth quadrant is negative theta. Now, if you notice the region given to us, the domain is negative half pi to positive half pi. That means it is in the first quadrant or it is in the fourth quadrant. We do not have this quadrant, so we'll ignore that. So what I need is only negative theta. So alpha is negative tan inverse. First of all, alpha will be 0.588 radians. So half x is negative 0.588, which means therefore my theta will, which is half x, that becomes negative because it is negative theta. So x is negative 0.588 times 2, negative 1.18 radians. Let's try number 2. Find the expression for f inverse x and find the domain of f inverse x. Fx is 3 tan half x minus 2. So let y become fx. So y is 3 tan half x minus 2. So tan half x is, I'm setting 2 to the other side first. So that's 2y, and then I have sent 3 to the other side. So it becomes not 2y, y plus 2 over 3. So half x is tan inverse y plus 2 over 3. So x is 2 tan inverse y plus 2 over 3. Since fx equals y, x is f inverse y. I'm sending f to the other side, the function to the other side. So I'm writing f inverse y equals 2 tan inverse y plus 2 over 3. So f inverse x is 2 tan inverse x plus 2 over 3. Now the domain given to us is negative pi over 2 less than equals x less than equals pi over 2. So f of negative pi over 2 is 3 tan half times negative half pi minus 2, which is same as 3 tan negative pi over 4 minus 2, which is 3 times negative 1 minus 2, negative 5. All right, let's try let me draw the line like that. I don't have the space there. All right, now f of half pi is 3 tan half of half pi minus 2. So it's 3 tan pi over 4 minus 2. So that's 3 tan pi over 4 is 1 minus 2 is 1. So range of fx is negative 5 less than equals fx less than equals 1. So domain of f inverse x, remember the range of fx is the domain of f inverse x, only that fx becomes x. So negative 5 less than equals x less than equals 1. Range of fx is domain of f inverse, and domain of fx is range of f inverse. That's what we write. Right. So that's done. Let's try the next one. Sketch on the same diagram the graph of y equals fx and y equals f inverse x. Let's draw the graph of y equals fx. Now I'm drawing. All right. Let me draw the line y equals x. Because why am I drawing the line y equals x? Because the fx and f inverse x are reflection of each other in the line y equals x. That's why I'm drawing line y equals x. All right. fx is tan inverse 3 tan half x. All right, so I'm trying that. It has an asymptote at negative pi over 2, and positive pi over 2. So I'm drawing the equation of that. It passes through negative 2. And that's halfway is, okay, that's pi over 2. So that's pi over 4. Halfway is pi over 4. That's negative pi over 2. The halfway is pi over 4. All right. It passes from negative 2 then more than pi over 4. Something like that. So, sorry. Not like that. Pi over 2 is asymptote. Sorry. So it should go like that. And then reflection in y equals fx. So I'm drawing that 1 and 2. So it's passing from there. This is changing. So I have that. So sorry. So the line becomes like that. Y equals f inverse x, and that's y equals fx. All right. It passing through origin.